Welcome to a slow, beginner-friendly lesson on pytest fixtures and mocking in Python, made for absolute beginners. Real-world pytest. In the last lesson you wrote your first tests. Today we go one step further into real-world pytest. We meet fixtures, a clean way to share setup code across many tests. We meet conftest.py, the file where project-wide fixtures live. And we learn mocking, how to fake an external call so your tests run fast and never touch the network. These three tools turn pytest from a toy into a professional toolkit. Three big tools. Here is the project layout we will use. Source files under src, users.py for business logic, github_api.py for code that calls an external service. Under tests, notice a new file, conftest.py. This is special to pytest. It holds fixtures and hooks that every test in the project can use, automatically, without imports. Hold that idea. Conftest.py is the shared toolbox for your whole test suite. The shared toolbox. Set up the project with UV in it. Add requests as a runtime dependency. The app actually needs it to call the API. Add pytest as a dev dependency with --dev, only developers need it. UV records each in the right section of pyproject.toml automatically. When you ship the app, requests comes along. When developers clone the repo, pytest appears via UV sync. 2 lines, 2 correctly classified dependencies. 2 deps, 2 groups. You will be running pytest constantly, so learn the useful flags. UV run pytest runs everything. Pass file function name to run one specific test, invaluable when you are iterating on a single failure. -s tells pytest to show any print statements in your tests, which it normally hides. Most of the time, plain UV run pytest is enough. The other flags earn their keep once your test suite grows past a handful of files. The flags you keep. Fixtures are how setup code stops being repetitive and starts being reusable. Setup, reusable. What is a fixture? It is reusable setup code that runs before your test. Need a fresh list to test against? Write a fixture that returns one. Need a temporary database? Write a fixture that creates it. Need a sample user object? Fixture. Tests ask for the fixture by name, and pytest injects whatever the fixture returns. This pattern, giving tests what they need instead of letting them build it themselves, is called dependency injection, and it keeps your tests short and focused. Inject, don't build. Here is the smallest possible fixture. We decorate a function called sample_user with pytest.fixture. It returns a dictionary with a name and an age. Then we write 2 test functions, and each one takes sample_user as an argument. Pytest sees the argument name, finds the matching fixture, runs it, and passes the return value in. 2 tests, same setup data, no duplication. Change the fixture once, both tests see the new data. 2 tests, 1 source. How does the wiring actually work? You declare a parameter on your test function, say, sample_user. Pytest looks at the name, hunts for a fixture with that exact name, runs the fixture function, and passes the return value as the argument. Your test never builds the data itself, it just receives it. This keeps the test body short and laser focused on the behavior being checked, not on the scaffolding. Name-based wiring. When setup is shared, tests get shorter and clearer. That is the entire point. Short and clear. Here is the life of a fixture. Pytest collects your test. It notices the test wants a fixture. It runs the fixture function, which builds and returns whatever the test needs. The test runs with that value. When the test finishes, pytest runs any teardown code the fixture registered, closing files, dropping tables, restoring state. Then the next test starts fresh. Default scope is function, 1 fresh fixture per test. You rarely notice this dance, but it is happening every single time. Setup, run, teardown, fixtures have scope. The default is function scope, a fresh fixture is built for every single test. Module scope builds it once per test file. Session scope builds it once for the entire pytest run. Use session scope for expensive things like starting a database. Use function scope for cheap things where isolation matters. Choosing the right scope is a balance between speed and isolation, and it is one of the most useful skills in real pytest work. Pick the right scope. When a fixture is useful across many test files, do not copy and paste it. Put it in conftest.py. Any fixture defined in conftest.py is automatically available to every test in the same folder and below, no imports, no plumbing. Pytest discovers it by magic. This is the single biggest quality of life feature in pytest, and it is what lets large test suites stay DRY, don't repeat yourself, without becoming a tangled mess of imports. Auto-available. Here is conftest.py in action. We define sample_user in conftest.py. Then in test_users.py we use it, with no import statement. And in another file, test_elsewhere.py, we use the same fixture again, still with no import. Pytest finds it automatically because of where it lives. This is how you share setup across an entire test suite without copy-paste or import tangles. No imports needed. A mock stands in for the real thing, so your tests can focus on what you actually own. A controlled fake. What is a mock? It is a fake that stands in for a real object or call. If your code calls an external API, you do not want your test to actually hit that API, it would be slow, flaky, and might cost money. Instead, you replace the real call with a mock that returns whatever you tell it to return. Your code thinks it called the real thing. Your test runs in milliseconds, with no network involved. Mocks are how you test the messy, connected parts of your code cleanly. Stay fast and isolated. Here is the problem mocking solves. Get_user calls the real GitHub API. If we tested this naively, every test run would hit github.com, slow, rate limited, and dependent on the network being up. Worse, GitHub might change its response shape and break our tests for reasons that have nothing to do with our code. We do not want to test GitHub. We want to test that our function handles the response correctly. That is what mocks are for. The problem: the standard mocking tool is unitest.mock.patch. Patch temporarily replaces an object with a mock for the duration of a test, then restores the original automatically. You can use it as a decorator on the test function, or as a with statement inside the test. The most important detail is where you patch. You patch the object in the module where it is looked up, not where it is defined. Get that right and mocking just works. Patch where it's used. Here is patch in action. We decorate the test with patch, pointing at where requests.get is used, inside my_project.github_API. Patch passes a mock object into the test as mock_get. We tell the mock, when your JSON method is called, return this dictionary. Then we call get_user, and our code happily uses the mock without knowing it is fake. The test runs offline, in milliseconds, with no GitHub involved. Mock the call. The pattern for mocking an HTTP call has 3 steps. First, patch requests.get at the location where it is used, that means patching it inside your module, not inside the requests library. Second, set up what the mock returns, usually return_value.json.return_value equals some dictionary. Third, optionally assert that the mock was called with the right arguments. Follow these 3 steps and your network code becomes fully testable offline. 3 steps. Here is the full pattern. We patch requests.get inside our module. We give the mock a dummy return value. Then we call get_user with the string ADA. Finally, we assert that the mock was called exactly once, with the exact URL we expected. This proves 2 things at once: that our code returns the right shape, and that it builds the right URL. No network, no rate limits, no flakiness, just a fast, deterministic check. Assert the call. When should you mock? Mock external calls, anything that leaves your process, HTTP, databases, file system, the clock. Mock slow things so tests stay fast. Mock things you do not own, so their failures do not become your failures. But do not mock the code you are actually testing, that defeats the point. A test that mocks everything proves nothing about your real code. Mock the boundaries, test the inside honestly. At the boundaries, quick self-check. Can you write a fixture that returns a dictionary? Can you explain why conftist.py needs no imports? Can you patch requests.get inside one of your own modules? Can you say why you would mock an external call instead of letting the test hit the real thing? If any feels shaky, rewind the matching section. You should leave this lesson comfortable with the 3 biggest tools in real Pytest work. Say each out loud. Here is the lesson in one breath. Fixtures keep your setup code DRY, define once, inject anywhere. Conftist.py makes fixtures available across the whole project without imports. Mocks replace slow, external, or unreliable calls so your tests stay fast and deterministic. The golden rule: mock at the boundaries, test the inside honestly. Master these 3 tools and you can test any Python code, no matter how connected it is to the outside world. One breath. Next we leave testing and talk about packaging. So far you have written scripts. We will turn one of them into a proper installable package, something other people can pip install or UV add and run as a command. We will meet the project.scripts section of pyproject.toml, which lets you expose a function as a command line tool. The arc closes, you can write code, test it, and now share it as a polished package. Packaging next. Thanks for meeting fixtures and mocking. Next we package a script as an installable Python project. 3 tools, mastered.